Decisions, decisions. Oh, those decisions. What is the correct method to use when solving a trigonometric problem? Decision number 1. When trying to determine which is the correct method to use, your first decision is, what kind of triangle am I given? Am I given a right-angled triangle or a non-right-angled triangle, which could be acute or it could be obtuse? Decision number 2. If the triangle contains a right angle, then use one of the primary trigonometric ratios. But if the triangle does not contain a right angle, then you have another decision. Do you use the sine law or do you use the cosine law? Now, if you've decided the way to go is a primary trigonometric ratio, oh, you guessed it, another decision. Which ratio to use? The 3 that you have to choose from are sine theta, which is opposite over hypotenuse, cos theta, which is adjacent over hypotenuse, and tan theta, which is opposite over adjacent. Let's keep these in reference here as we talk about the steps to follow. Given a diagram, or you may have to sketch your own diagram. Regardless, find the given reference angle. Name the sides that are given: opposite, adjacent, hypotenuse. List what is given in the question. This will help you to know which formula to use. Then use the formula that matches what is given and what you are trying to find. Okay, so you know you don't have a right angle triangle. So now you have to decide, do I use the sine law or do I use the cosine law? Let's take a closer look at the sine law. The sine law is used when you have an acute or an obtuse triangle. There must be an angle and its corresponding side length given. There must be also another given side or angle. The formulas to use, you have 2 choices. Sine A over A equals sine B over B equals sine C over C. This would be used if you're trying to find the value of an angle. And the second one, A over sine A equals B over sine B equals C over sine C, is used if you're trying to find a side. And now the cosine law. The cosine law is used when you have an acute or an obtuse angled triangle. To use the cosine law, though, you must have either the side, a contained angle, and a side. The word contained means in between the 2 sides, much like meat in a sandwich. Or a side, side, side. The formula, A squared is equal to B squared plus C squared minus 2BC cos A, can be used to find any of the sides or any of the angles. Now, some examples. Here is example 1, as shown in the diagram. Triangle NMP. We're trying to find side M. So how do we do that? You got it. Label the reference angle. Label the given sides relative to the given angle. Opposite, hypotenuse. You are given the hypotenuse and the opposite side. Use the sine ratio because the sine theta, or reference angle, is equal to opposite over hypotenuse. You could just as easily have used cos or tan. Example 2. Identify what is given in the question. We have the angle and corresponding side, theta and 5 centimeters. We have the angle and corresponding side, 87 degrees and 14 centimeters. You are given then 2 angles and 2 corresponding sides. We know then this is the sine law. Since we're trying to find the angle, we will use it in the form sine A over A equals sine B over B equals sine C over C. Example 3. Here we have another triangle. What do we have? Identify what is given in the question. We have a side, oh, and we have a contained angle. That's our clue that we will use the cosine law. A squared is equal to b squared plus c squared minus 2bc cos of A. Now, let's put trig to work while completing Lesson 4 project.